problems in related rates. Okay, second one is the interval of increase and decreasing function. Okay, third, the first and second derivative test. Then number 4, graph of polynomial, rational function and asymptote. Okay, and then number 5, maximum and minimum values of a function. Okay, these 4 subtopic ni related subtopic number 2 until number 5. Okay, and then number 6, okay, apply maximum and minimum problems. And last application, okay, Rolle's theorem and mean value theorem. So there are 7 learning outcome in this chapter. So application of differentiation. Okay, first learning outcome, okay, related rates. Okay, ada soalan tak? Okay, related rates-nya ni ada pembetulan ni sikit kat sini. Ni. V dia ni. Jawapan dia hari tu saya salah. Saya tulis kan? Ya. 5x plus 2x square plus x cube. Ni ada pembetulan sikit kan dekat sini. Okay, then find dv over dx. Okay, ada soalan tak untuk ni? Related rates. Related rates kita apply kan chain rule. Application of chain rule. Tak ada? Boleh faham ni?
Boleh, madam.
Ada madam. Boleh.
Boleh Tahu kan apa nilai yang kita nak cari kat sini? Nilai dia beri untuk related rates ni you perlu fahamkanlah dia punya ayat ni. Sentence dia.
Madam.
Ya?
Unit tu kalau tak letak kena tolak markah ke?
Last ni. Boleh je tak letak. Better
okay.
tapi letak lah.
Okay.
Jawapan dia, dalam jawapan tak ada unit juga kan? Boleh je lah. Tapi kalau boleh letaklah unit dia. Okay, yang exercise ni ada tak soalan? Boleh jawab tak semua?
Boleh.
Boleh Ayo boleh cuba jugalah dalam buku revision guide tu ada extra exercise kan, related rates kan? Tutorial. Kita tengok apa tutorial 13. Bolehlah cuba buat 37 tutorial 13. Based on past year question related rates. Biasa akan keluar satu soalan lah untuk related rates ni. Okay, kalau tak ada soalan, tengok yang ni. Okay, increase and decreasing function. Okay, yang ni boleh tak hari tu, last week? Boleh faham tak? Video dan soalan dan cara nak buat. Boleh faham tak? Kita akan gunakan increasing and decreasing function ni untuk yang ni lah yang saya cakap tadi. Subtopic 2 until 5 ni dia relate. 2, 3, 4, 5 ni dia relate. So maksudnya awak kena fahamkan dulu daripada awal ni lah interval of increase and decreasing function. Ni. Boleh faham ni?
Boleh madam.
Boleh? Okay, so kalau tak ada soalan yang ni, okay, kita pergi new subtopic. Okay, subtopic 3.3. Okay, the first and second derivative test. Okay, first and second derivative test. Okay, normally we use this test. Okay, the first and second derivative test. Okay, to locate the critical point of a function. Okay, before this in subtopic 3.2, we have learned how to find the critical value. This one critical value dah, and you all cari nilai f prime equal to 0 kan. Kat sini f prime x equal to 0. So value x is equal to critical value. Okay, for example, this example. Okay, f prime x is equal to 8x minus 3. So equal to 0. So x equal to 3 over 8. So 3 over 8 is the critical value. So in this chapter, okay, we want to find the critical point of a function. Okay, and then the second objective in this subtopic, okay, to determine whether each point, okay, is a maximum point, minimum point, or inflection point. So tadi kita nak tahu critical point. Then second, we want to find the maximum, minimum, or inflection point. And the last one, okay, give the information about concavity of a function. So there are 3 objectives in this subtopic. 3 objectives based on this first and second derivative test. Okay, now we look at, okay, what is the critical point? Okay, the previous one we have learned how to find the critical value. Okay, critical value of x where f prime x is equal to 0. So when we find the critical value, so we can find the critical point, or known as the stationary point. Okay, so the critical point is equal to x fx. Okay, in term of xy lah kat sini. We have xy value. So xy is the critical point. So you all perlu tahulah beza what is the critical value and critical point. Okay, look at example 1. Okay, find all the critical point. Okay, all function. Okay, this function. X power of 4 minus 4x cubed plus 4x squared. Okay, first step, you have to find the critical value. So, to find the critical value, we have to differentiate the function fx. So, first step, find fx, f prime x. Is equal to 4x cubed minus 12x squared plus 8x. Okay, then second step, okay, f prime x is equal to 0. Then find x. So fx cubed minus 12x squared plus 8x equal to 0. Now we can factorize this function. Find the value for x. So for x, okay, and then factorize. Ataupun you all boleh terus tekan calculator. Nanti akan dapat the value for x. Okay, kalau factorize kita akan dapat x.
X tolak 2, X tolak 1.
x minus 2, x minus 1 equal to 0. So x is equal to 0, 2 and 1. Okay, so this is the critical value. So find all the critical point. Ayo carilah when x equal to 0. So fx, we substitute into original function. So fx equal to
0.
0. So akan dapatlah kan. Point dia, critical point. Critical point. Itu 0, 0. Okay, when x equal to 2. So fx equal to, substitute x equal to 2 into this function.
1.
So 2.
1.
1 ke?
Salah.
Tekan kali tu lah. 2 to the power of 4 minus 4 times 2 to the power of 3 plus 4 times 4. Berapa? Yang lain berapa?
0.
Dapat 0 kan? 0. 0 lah. Okay, when x equal to 1. So fx equal to
1.
x to 1. So 1, 1. Okay, so there are 3 critical points. Yeah, critical point you are. Okay. Okay, ada soalan tak ni? Find the critical point.
Tak ada, madam.
Okay, after we have found the critical point, okay, we can use the first derivative test to find to determine whether the critical point is extremum point, either minimum point, maximum point, or non-extremum point. So we use the first derivative test. Okay, given fx is continuous in the interval AB, okay, if C is the critical value, then the critical point CF can be classified as follow. So interval AC, if the sign for F prime positive and at the interval CB sign of F prime negative, so we have the maximum point. Or we call it relative maxima. Kan? Lagi satu term dia, relative maximum. Okay, if the interval from A to C, C is the critical value, negative, and interval, the critical value to B greater than critical value lah. We test the value. So F prime is positive, so negative, positive, we have the minimum point or relative minimum. Okay, when the sign of F prime for the interval AC positive and for the interval CB positif. Okay, positif, positif. Dua-dua sign yang sama lah. Or we have negatif, negatif. Okay, so no extremum point. Kat sini no extremum point or no relative extremum. Or no relative extremum. No relative. Okay. So kita gunakan table ni untuk tentukan lah. Tadi kita dah dapatkan critical point lah. Kita nak tentukan 0, 0 ni adalah minimum point or maximum point ataupun no extremum point. Setiap satu point ni kita nak tentukan. Dia adalah minimum point atau maximum point ataupun no extremum point. So kita gunakan test yang ni lah. First derivative test. Okay, look at example 1. Okay, find all the critical point of fx. Sama lah macam tadi kan. F prime. First we find f prime x. Okay, so 3x squared plus 8x minus 3. So equal to 0. Then we factorize. Ataupun you terus je lah boleh dapat kan. X dapat apa? X equal to 1 over 3. And x equal to negative 3. Dapat tak ni? So ni adalah critical value. This is the critical value. So what is the critical point? Okay, when x equal to 1 over 3, okay, we substitute the value x equal to 1 over 3 into this function, into the original function. Masukkan dalam original function untuk tahu dia punya critical point. Okay, so when x equal to 1 over 3, y equal to, tekan calculator.
Negatif 1. Negatif 1.
Masukkan dalam function ni, original function. So 1 over 3 kan? Maksudlah 1 over 3 cube. Masukkan kat sini. 1 over 3 cube plus 4. 1 over 3 square minus 3. 1 over 3 plus 8. Dapat berapa? Nilai dapat berapa? Betul ke 1?
Medan nak perpuluhan atau pecahan?
Buat dalam pecahan je lah.
Macam 202 per 27.
202 per 27 kan?
202
Sekejap
per 27.
202 over 27 Depan dia. Saya salah tekan calculator tak tadi? Jawapannya pertama tadi. Okay, another critical point. When x equal to negative 3, so fx equal to, we substitute into original function, negative 3.
26.
Kita dapat 26. Okay, so we have two critical point. Okay, and then, next question. Okay, determine extremum point. So, extremum point ni kita tahu lah dia nak cari maximum point or minimum point ataupun no extremum point. No extremum kan. Okay, using the first derivative test. Okay, kita dah ada critical point ni. Kita nak tahu which one yang ni, salah satu ni. So, we use the first derivative test lah. Yang kedua ni. First derivative test. You all perlu test setiap satu lah kat sini. Setiap satu critical value dia. Okay, when x. Okay, kat sini ada. Okay, kita test dulu lah yang untuk ni 1/3 1/3. So, f prime x. Okay, kita test. Okay, so untuk ni test kita ambil nilai, kita ambil the whole number yang tak ada fraction, non-fraction yang less than 1/3. Apa? Kita boleh test 0 lah kan? 0. Boleh tak yang less 1/3. Kita ambil yang nombor menghampiri lah, nombor non-fraction. 0 kan? So 0 kita dapat
-3.
dapat negatif kan? Awak tulis je negatif. Nilai dia tak payah tak apa. Okay, untuk yang ni greater than 1/3, we test 1 lah. Contoh kita test 1. Kita ambil nombor yang paling dekat Awak jangan ambil yang paling jauh. Paling jauh nanti kadang-kadang dia tak akan dapat. Nanti dia akan ada konflik juga. Tak dapat nilai. Okay, dapat apa? Positif kan?
Positif.
Dapat positif. Okay, so negatif, positif. Okay, negatif. Decrease lah, negatif. And then positif. Negatif, positif. So we have kat sini. The extremum point is minimum point. Ini minimum point lah, minimum point. So 1/3, 202/27. Okay, table ni awak kena tunjuk dalam awak punya calculation. Table ni first derivative test. So kena tunjuk lah less than the critical point. So sign dia kena tunjuk sign je. Tak perlu pun tunjuk nilai dia. So f prime x sign for x prime x for less than or greater than the critical point, the critical value. Okay, then kita test for the critical value -3. Table kena buat ni. So x -3. Okay, less than -3. We test -2. -4. Okay, greater than -3, we test -2. Okay, masukkan -4 into f prime. Masukkan dalam ni. Masukkan dalam ni lah. Function ni. Yang awak dah differentiate tadi. So 3 times -4 square plus 8 times -4 minus 3. So we have positive sign. Boleh? Okay, when we substitute -2 is the value greater than -3. So we substitute -2 into the function f prime. So we have negative sign. Boleh ni? Okay, so positive. Ada increase ni, positive to negative. So this point, -326 is the maximum point. So tengok ni, kalau yang dia ke bawah ni minimum point lah. Ke atas maximum point. Okay, ada soalan tak? Boleh faham?
Boleh, madam.
Boleh?
Boleh.
Now we look at example 2. Okay, find all the critical point of fx equal to ln x over x square. Okay, first we arrange the function of fx into ln x times x to the power of -2. Then we find f prime x. Okay, using quotient rule. Find fx using quotient rule. Ataupun yang ni guna product rule lah. Ataupun nak guna quotient rule pun boleh. Ini product rule kan. Yep. Depend lah awak nak guna. Yep. Product rule. Okay, contohlah guna product rules kan. So f prime okay, we differentiate uv uv, differentiate u 1 over x times x -2. Okay, plus okay, ln x times okay, -2x -3. Then you boleh simplify lah. 1 over ni x cube plus -2 ln x over x cube. So akan dapat 1 minus 2 ln x over x cube. Okay, dapat yang ni lah. The f prime, the function for f prime. Then we find the critical value. Critical value. One minus 2 ln x over x cube is equal to 0. Okay, so 1 minus 2 ln x is equal to 0. So 2 ln x is equal to 1. ln x equal to 1 over 2. So x equal to exponent 1 over 2. Point, ambil point lah. 1.65. Ambil tu dia decimal point lah. Biasa kalau kita untuk sketch graph, kita ambil je lah 2 decimal point. Ataupun 1 decimal point. Okay, boleh tak ni? So this is the critical value. Okay, then find the critical point. Nak substitute lah the value x critical value into original function. Substitute into original function. So ln 1.65 over 1.65 square. Okay, dapat berapa? Cuba tekan calculator 1.65. Zero point one eight. Okay, so this is the critical point. Okay, and then determine the extremum point using the first derivative test. Okay, so we construct a table. So consists of the critical value 1.65. And then find the value less than 1.65 is 1 kan? 1. Then we substitute x equal to 1 into f prime. Substitute into f prime. 1 minus 2 ln 1 over 1 cube. Okay, equal to 1 kan? So positive lah, positive sign. Okay, boleh tak ni?
Boleh.
Boleh Okay, then greater than 1.65, we substitute value 2 lah, 2. So 2 times 1 minus 2 ln 2 over 2 to the power of 3. So it is negative sign. Kena check betul tak? Negative. Kadang ada nilai yang kalau tersalah tu. Ln 2. Tak negatif kan? Okay, so positive to negative. Okay, positive and negative. Ini positive. Ada increase lah. And then negative, decrease. So we have this point is the maximum point. This is the maximum point, 1.65, 0.18. Okay, table ni kena buat Table ni first derivative test ni. First derivative test. Ni ada markah Kena tulis lah, ni ada markah. Untuk semua calculation ni ada markahnya ni. Kena gantikan value greater than the critical point and less than critical point. And then sign. Tulis sign dia je lah kat sini. Positive or negative sign. Positive or negative sign. And then kat sini your label lah, the maximum point. So the critical point is maximum or minimum point. Conclusion dia. Okay, example 3 ni boleh try sendiri ni. Okay, ni so ni jawapan dia lah. Maximum point and minimum point. Boleh try sendiri. Okay, also example 4. Okay, example 4, for A, determine the interval fx is increasing or decreasing. Okay, ni previous subtopic kan, 3.2. Increasing and decreasing function. Then B, find the extreme point using first derivative test. Ni yang kita belajar lah. Kena construct table lah. First derivative test. Okay, ada soalan tak? Ni. So, ni contoh untuk first derivative test. Tak ada? Boleh? Boleh faham?
Boleh.
Boleh? Okay, now we look at this second derivative test. Okay, second derivative test is used to determine the concavity of a curve. Okay, concavity of a curve. Okay, fx is differentiable function in the interval AB. Okay, fx is said to be concave up if f double prime x greater than 0. Or we have the curve lies above the tangent line. Okay, this is the tangent line and the curve lies above the tangent line. Mangkuk yang ke atas lah ni. So it is concave up. Concave upward. Macam mangkuk lah kan ke atas. Above the tangent line. Okay, second one is concave downward. Okay, if the f double prime is less than 0 or the curve lies below the tangent line. Okay, ni ada correction sikit below dalam nota tu. Below the tangent line. So we have the tangent line and the curve lies below the tangent line. Okay, so this is concave downward or concave down. So for concave up, we have kat sini kita relate dengan yang sebelum ni lah yang dah belajar. So for concave up, we have this one is minimum point. And for concave down, we have the maximum point. Okay, for second derivative test, we can also use this test to find the point of inflection. The second objective for second derivative test to find the point of inflection. Okay, the point of inflection. Okay, if fx is continuous at AB and the concavity of fx change at C. Okay, in the interval AB, then CFC is called the inflection point. Okay, where C is, this one, C is the inflection value. Okay, so what is the inflection point in general form? Okay, ni in the definition using theorem. So the general definition, inflection point is the point where the curve change from concave up to concave down or from concave down to concave up. Maksudnya kita ada graph concave Contoh kat sini kita ada concave down kan. Okay, then kita ada juga graph concave up. Okay, normally this graph for cubic lah. Normally cubic and above. Dia ada up and down kat sini. Normally ni cubic ataupun greater than polynomial greater than 3 lah. 3 and above. And above. Ataupun ni contoh graf untuk cubic lah kan. Cubic. Cubic. We have concave down and concave up. So the inflection point is the point where the curve change to concave down to concave up, or from concave down or from concave, baliklah, from concave up to concave down. Okay, sini. So this is the inflection point. Ini the inflection point. Okay, so how to find this inflection point? Okay, first step, you have to find the f double prime of the function. Kita double differentiate lah, f double prime. So and then find the value for x. Okay, we let f double prime equal to 0. Then find the value of x. Okay, where x is the inflection value. X equal to c. X equal to c. C is the inflection value. Okay, sebelum ni kalau you all cari f prime x equal to 0, then find x. Kan, x kan. X adalah critical value kan. Okay, for second derivative test, x is the inflection point, inflection value. Okay, then step 3, we can find the inflection point. Okay, CFC. We substitute the inflection value that we have into the original value, into the original function. Sini original function. Substitute C into kita dapatkan inflection point. So perlu tahulah inflection point dia mesti ada nilai x and y, coordinate x and y. Okay, look at example 5. Okay, examine the graph of fx equal to x cubed minus 3x squared plus 4 for concavity. Okay, then find the point of inflection of the function. So kat sini nak tahu concave up or concave down kan. First you all perlu double differentiate lah. F prime. Find the F prime dulu. Okay, 3x squared minus 6x. And then find the F double prime. Six x minus 6 equal to 0. So x equal to 6 over 6 is equal to 1. So 1 is the inflection value. Okay, then find the inflection point. Masukkan, substitute into original function. So F1 equal to 1 cube minus 3 1 square plus 4 equal to 2 kan? 2. So we have the inflection point equal to 1, 2. Okay, so kita test ni. Kat sini test for concavity lah. You perlu double the second derivative test. F double prime. Okay, tadi kat sini kita dapat the inflection value is equal to 1. So kat sini 1 lah. The inflection value. Untuk second derivative test kita gunakan inflection value. Okay, so our test. The value less than 1 is 0. So test 0, substitute into F double prime. So we have negative, kan? 6 times 0 minus 6 is negative 6. So negative lah. And we test value greater than 1 is 2. Okay, so substitute 6 times 2, 12 minus 6. So 6 is positive. Okay, so kat sini you all tahulah the negative sign is concave down or downward. And this positive sign for F double prime is concave upward. Okay. Okay, yang ni kena tunjuk Dan conclusion. Okay, ada soalan tak? Ada soalan tak? Boleh faham
Madam nak tanya.
Ya?
Nanti jawapan akhir dia tulis macam tu je lah.
Yalah macam ni lah. Awak labelkan lah.
Okay.
Ataupun boleh buat satu box lagi lah. Satu box kan. Box kat bawah ni tulislah. So untuk yang ni 0 is concave down. So column yang untuk 2 ni concave upward. Boleh buat satu box conclusion dia macam ni lah. Sekejap. Buat satu box lagi kan. Tulis conclusion. So tulis concave down. Okay. So kat sini concave down. Awak boleh tahulah dia macam gini lah kan. Concave down. Concave up. Okay, example 6. Mana boleh try sendiri. Kita nak buat sesama. Ni no inflection. Jawapan dia no inflection point. Cuba tengok yang ni. Last apa? Example 7 nanti you buat sendiri. Example 6. Saya tunjukkan. Okay, examine the graph fx. Okay, cube. Xx is the quadratic function for concavity. Find the inflection point. So first, find the inflection value lah. Tu. Okay, f double prime 2. Okay, daripada sini pun kita dah tahu kan f double prime 2 is greater than 0. So, daripada sini kita dah tahulah ada concave outward. Okay, for all value of x. So therefore no inflection point lah. Therefore no inflection. Therefore no inflection point. We cannot find the inflection value kan from ni f double prime ni x. Okay, then find the concavity. Okay, concavity awak test using second derivative test. Okay, kita ni tak perlulah second derivative test sebab tak perlu sebab dia tak ada nilai x kan. Okay, jadi kita perlu buat apa? Concavity ni. Kita perlu gunakan, kita boleh gunakan the first derivative test lah kat sini. First derivative test pun kita boleh tentukan concavity dia. Kita boleh gunakan first derivative test lah sebab second derivative test dia tak ada inflection value kan. So we use the first derivative test untuk ni. First derivative test pun dia relate lah sebenarnya. Macam tadi kan saya mention first derivative test tadi. Yang ni tadi first derivative test pun kita boleh tahu kan. Kat sini concave down. Daripada sini concave down. Daripada sini pun kita tahu concave up. Okay, so find the first derivative test. Okay, kat sini tahu ni f prime x is equal to 0. So f prime x to x minus 2. So to x minus 2 is equal to 0. So to x equal to 2, x equal to 1. So 1 is the critical value. Dia suruh cari tak point. Tak ada. Tapi bolehlah cari point dia kan. Sini. So the critical point is equal to 1. Okay, substitute 1 into original function. Okay, 1 minus 2. 1 minus 2 minus 3. Okay, dapat negative 4 kan? Negative 3. Negative 4 kan? 1 kan?
Negative 4.
Negative 4. So negative 4 is the critical point. Tadi buat first derivative lah. First derivative test. So ni critical value is 1. So F prime. Okay, we test. Value less than 1 is 0. Test into F prime. So 0, 2 times 0, minus 2. So we get negative kan? Negative sign. Okay, then test value greater than 1 is 2. Okay, 2 times 2, 4 minus 2. Dapat positive. Okay, so negative, positive. Negative, positive. So kat sini kita adalah critical. So the critical point is 1, 4. 1, negative 4 is the minimum point. Or it is concave up. Upward. Soalan dia nak tanya concavity kan. For concavity. So kena tahulah concave up ataupun concave down. From the first derivative test. Table ni kena tunjuk. Dan boleh lukis lah ni, boleh sketch. Concave up or concave down. Ni perlu sketch lah ni. Sketch. Sketch concave up or down. Okay, ada soalan tak? Kita akan gunakan ni untuk sketch the graph. Nanti polynomial graph or rational function. Graph or rational function. Next subtopic 3.4. Okay, example 7 ni you all boleh